Logarithmic Differentiation, Part 1. This example here, this function, if we tried to do this with the quotient rule, that is find dy dx with the quotient rule, we'd have a lot of trouble. And so we're going to look for y prime using logarithmic differentiation. And the first thing we do is we say that if two functions y and this are equal, then the logs are equal. And so we say that we take the log of both sides. Now we can do a lot of expansion here with this using the properties of logarithms. And the first thing we can do is take, this is a quotient, so we can take the top minus the bottom. And that's what I've done here. Here's the log of the top of that expression. Notice I changed it to also to a fractional exponent here because we can use that later. And here we have minus the log of the bottom. This is a product, so we can change this into a sum, and we have to be careful when we do this because we'll have to put it in parentheses because we're going to have to distribute the negative here to the two positive values, two positive terms, that is. And so we've got it somewhat expanded. Now I can bring the exponents out front, can I? And that's what I'm going to do next. Here we go with this. I've got the 1/4 out front, and I got the 2 out front, and the 1/2 out front. Now all I have to do is simplify this a little, distribute. Okay. Now we've got it expanded as much as we can, and we notice that if we differentiate implicitly, and that's the next step, step 3, differentiate implicitly, that these are very easy. Of course, the log of y is y prime over y, and this becomes 1/4 times 5x minus 7 prime over 5x minus 7, and these become very simple derivatives. You might stop the movie and convince yourself that all of this is true. And then the final step, of course, is to multiply both sides by y. And we're almost done. In fact, we have y prime, what y prime is, but we can make this all in terms of x if we want, because we know what y is from the expression in the very beginning. Y equals, here it is, substitute in for y equals this 4th root of 5x minus 7 over x squared times the square root of 3x plus 1. So you put that in front, and there you've taken the derivative.